Hello everyone. Today's video lecture is on difference between CFA and SEM. There's a specific reason why I have chosen this particular topic. There are a lot of research scholars and young faculty who have a lot of doubts regarding CFA and SEM. So today's session is all about CFA and SEM and the difference between them. So let us first start with understanding, the similarities and the differences amongst them. Now, they're both part of multivariate analysis methods. Okay, so we can think of variables as multiple variables. When we have more than two, they are called as multiple variables. And techniques, any technique which is used to analyze the relationship amongst multiple variables is called as multivariate analysis. We could also have a bivariate where we have only two variables. So bivariate is a special form of multivariate analysis. Now in multivariate analysis, we can basically divide them into two broad groups: analysis of dependence and analysis of interdependence. Now, why do we say analysis of dependence? Because we are assuming that one of the variables is independent and the other is dependent. Like for example, let us look at two variables: advertising and sales. Now, we advertise because we hope that by advertising the sales also increases, or the sales will increase. So there is a relationship amongst advertising and sales, and we assume advertising to be independent and sales to be dependent. So this becomes a technique of dependence, because here one of the variable is a dependent variable. So when we look at uh, the analysis of dependence, two broad technique comes to our mind. Two broad techniques come to our mind. One is the multiple regression, the other is the structure equation modeling, which we'll be discussing about in this particular session. Then comes your analysis of interdependence. Here the variables are not thought of in terms of independent and dependent variable. They're all assumed to be independent of each other. Okay, and many of the analysis that we do, such as cluster analysis, factor analysis, and in factor analysis we have EFA as well as both CFA, analysis of variance, where we are comparing more than two groups, or we are comparing two groups or lesser. We use some technique called as a t-test. So these are all techniques of interdependence, whereas regression, structure equation modeling, these are techniques of dependence where you have dependent variables and independent variables. So basically we are examining some sort of, in layman terms, cause and effect relationship. So outcome variable, predictor variable, these are all related to analysis of dependence. Now let's have a look at the family tree of SEM in order to understand the key differences and the similarities. Let us look at the family tree of SEM. So on the top side, you can see you have the t-test, ANOVA. So this is a separate family, whereas we are talking, our discussion is focused on this particular aspect of the family tree. Now all analysis, the structure equation modeling, or whether it is factor analysis or regression or any of these analysis, which is the building block is a correlation and a regression analysis. So whether it is a factor analysis or whether it is multiple regression, or whether it is confirmatory factor analysis or exploratory factor analysis or structure equation modeling, the building block is, or the building blocks are always correlation analysis and regression analysis. That's why they are part of the family. Now, the important thing to note is that factor analysis, there are two types: exploratory factor analysis, which we call as EFA, and the other is called as the confirmatory factor analysis. Similarly, we have something which is called as a multiple regression, and we have something which is called as a structure equation modeling, which we sometimes refer to as SEM. So multiple regression, when we say multiple regression, we are assuming that it includes, for our understanding, bivariate regression also, simple regression as we call it, simple regression. So if we move on to the next slide, let us look at the differences between, because this topic is about CFA and SEM. CFA belongs to, like EFA. CFA and EFA, they are part of factor analysis, and they are analysis of interdependence. So the similarity is between EFA and CFA. So EFA is exploratory and CFA is confirmatory factor analysis. But if you were to relate this with anything, if you were to relate CFA with anything, it has to be related with EFA, not with structure equation modeling, because the analysis that you perform in CFA is similar to what you do in EFA. So EFA and CFA are similar. Similarly, in techniques of dependence, regression and SEM are similar in the kind of analysis that they perform. SEM is visual, regression is generally or traditionally has not been what you call as a visual analysis. So visual analysis is what you call as SEM. And SEM is where you have latent variables. So I'll explain this in the coming slides. Now let's come back to the technique of interdependence. So EFA can very easily be performed on SPSS, Stata, Jamovi, it's a free, or even R. CFA can be performed on softwares like MOS, Lavan, which is part of R, Lizrel, M+. It can also be done on Jamovi. Okay. Why people confuse CFA with SEM is because of one simple reason, that CFA is usually done on visual softwares like MOS and Lizrel. So people think that CFA and SEM are the same thing and they use these words interchangeably, which is wrong. CFA is from the family of factor analysis and it is a sister of EFA. So we have the at the top we have factor analysis, and we have, and from that particular family we have the EFA analysis and we have the CFA analysis. CFA is done on these softwares and more. There are many other softwares which I have not listed here. EFA is generally done on these software. These are the popular softwares. While regression, we can do it on SPSS, we can do it on Stata, we can do it on R, we can do it on Jamovi, we can do it on Excel. While structure equation modeling can be done on MOS, it can be done on many other softwares apart from the ones which have been listed here. So we R means Lavan. So we can do all these things here in structure equation modeling. Now the question is that what is the difference between SEM and regression? They're all very similar sounding words. So regression also does the similar analysis and the outcome of structure equation modeling is also similar. In regression, we do not have latent variables. In structure equation modeling, or SEM is capable of modeling latent variables. So we'll move on to the next slide and we can see. If we look at factor analysis is, like I said, is a fundamental component of structure equation modeling, as we saw in the family tree. So factor analysis is a fundamental component, and factor analysis basically is of two broad types. One is called as the exploratory factor analysis and the other is called as the confirmatory factor analysis. So the top two, if you can see here, the three primary applications of factor analysis, they explore the data for patterns and data reduction. So here what we are trying to do is we are trying to do an exploratory factor analysis, and the third one is a confirmatory factor analysis. Now EFA reveals the pattern among the interrelationship of the variables. So what are we trying to say here? We are trying to say that assuming we have a questionnaire. Okay. I have a questionnaire here, and this questionnaire is about the student feedback, and it is basically about the faculty feedback. The feedback is provided by the students on the faculty who teaches a particular course or might be teaching multiple courses. Okay, so we have here, these are, the rank of the faculty and the gender of the faculty and the number of years that he has taught and the student's gender in this particular. So we have a questionnaire, and these are the questionnaire items or the scale items, as you would want to call it. So these are some of the scale items which have been represented as item 1. So the labels, so the names are item 1 and these are the labels that you see here. So these are, in simple words, these are the questions that you would want to have in your questionnaire. And based on this, we have collected the data. So the data looks something like this, and you can see, so this is the faculty gender. So we have a code, 1 for male and 2 for female. Years of teaching, student sex, that is the gender of the student. So 1 stands for male and 2 stands for female. And then we have the questionnaire or the scale item. So you can, I will just hover here and you can see item number one. Instructor is always well prepared. So this is actually a Likert scale where the students have been asked to rate the faculty from 1 to 5, and this rating is actually based on the Likert scale where the students have to agree or disagree with certain scale items, and so on and so forth. So we have around 9 items here in total. So 9 items, each student has given his or her response on those 9 items. So once we have these 9 items, as you can see, here we have only listed 6. Now what we do is in EFA, we run the EFA analysis. And the factor analysis will tell us how these items are clubbed together in the form of factors. So there is always a possibility that these items, like for example, in our previous example, we had 9 statements. Here we have 6 statements. So what is the possible factor solution that we may have here? We could have a 3-factor solution. We could have a 2-factor solution. We could have a 1-factor solution. So ultimately, EFA finds these factors for us statistically. It gives us the statistical clubbing or grouping of items. These are what we call as the scale items, and it will group these together. And the ones which are similar will be grouped together, statistically similar, they will be grouped together, and you may call them as factor 1, or you may give them a theoretical name, which you should. Similarly, it will group some of the questions together and it will call them as factor 2, or the statements, and it will call them as factor 2, and you have to give it a theoretical name. So let's assume, for the sake of simplicity, that we have only 2 factors out of this EFA exercise. So what do we mean by EFA? EFA is an exercise where you don't know which statement becomes a part of which factor, and you don't even know how many factors are there in your how many factors you are going to uncover. So it's basically an exploratory exercise. So you will have to see whether 3-factor solution is good or 2-factor solution is good. Now what is CFA? In CFA we already know the solution. Like for example, we have already done the study, we have done an EFA, and we find that the EFA is wonderful, the analysis is wonderful, and we publish a paper, and some other researcher picks up our questionnaire, or the scale as you would want to call it. He picks up our scale. Now that particular researcher will have to run a CFA analysis. And what is he trying to do in that particular CFA analysis? He is trying to collect the data and see if his data fits the factor structure. So what he is trying to do is he's trying to confirm the factor structure of a previous study. So that is why it is called as confirmatory factor analysis. So what are we trying to do here? We are trying to confirm the factor structure of a previous study. So CFA, we already know the relationships. We know that X1 is a part of factor 1, X2 is part of factor 2, X3 is part of, sorry, X2 is part of factor 1, X3 is part of factor 1, while X4, X5 and X6 are part of factor 2, and they are not part of factor 1. This is what we call as confirmatory factor analysis. Now, as I said a few minutes back, EFA is done on, generally, most of the researchers prefer to do EFA for the sake of simplicity, and because of the fact that the software is easily available, they do this exercise on EFA. CFA, generally, researchers prefer to do it on softwares like MOS and Lizrel. Nowadays, you have some other softwares which have come up, softwares like Lavan, and which are part of R. You have Smart PLS, which is an altogether different thing, which we will discuss in forthcoming videos. So CFA is done on MOS generally, like EFA is done on SPSS, because they're both popular softwares. They can be done on any software, provided that the software supports it. Okay, so we saw that in the previous examples, in the previous slides, we have seen that there are different softwares which can do a CFA analysis, and there are different softwares which can do an EFA analysis, and there are some softwares which can do both. For example, Jamovi can do an EFA, it can do a CFA. Now, the point is, what is the distinction between CFA and structure equation modeling. This is where most of the researchers get confused. The point that I'm trying to make here is that people tend to confuse CFA and SEM, CFA, or they tend to confuse between these two terms for the simple reason that they are both part of, they're both done on the software, easily available software, let me put it this way, which is called as AMOS. So most of the people think that CFA and SEM are one and the same thing, but that is not correct. That is incorrect. CFA is completely different from structure equation modeling. In structural equation modeling, we are trying to analyze the cause and effect relationships in layman terms. We are trying to predict something. So there the variables are, in simple terms, independent and dependent variables and some intervening variables. Whereas in EFA and CFA, you don't have these kind of things. Here, what we are trying to do is we are trying to look at the structure of the factors. Whether x1 is going to be part of factor 1, x2 is going to be part of factor 2, x3 is going to be part of factor 3, or is it going to be part of factor 2? This is what we do in EFA. And in CFA, we confirm the factor structure. So in terms of similarity, EFA and CFA are very similar. They are brothers and sisters, as if you want to call it, or they are sisters or they are brothers, if you want to call it that ways. Whereas if we were to talk of structure equation modeling is very similar to regression analysis. Okay, with a lot of advantages over regression analysis. But if you were to talk in terms of the types of analysis and the technique of analysis, they are they are from the same family. So you could call them brothers and sisters. Regression has its own limitations. Okay, so let's move ahead. What happens from a CFA? We can move to something called as structure equation modeling. Now, if you go back to our previous example, we can see there are two factors, factor 1 and factor 2, and we have a curved bi-headed arrow. Okay, so that means this, what does this curve indicate? It indicates correlation between these two factors. And because they're part of the same set of questionnaire and they may be measuring. So if you look at this particular model, the same thing. But what has happened now, instead of that curved bi-headed arrow, what we have is we have one simple straight arrow, which is depicting the relationship. For example, this exogenous construct, exogenous is the word for independent variable in SEM terminology. So exogenous variable is impacting the endogenous variable. So endogenous variable includes dependent variable, and mediating and moderating variables are also part of endogenous. So in SEM terminology, simply put, this is the independent variable and this is the dependent variable. And what we are trying to say here is, if we go back to our previous example, advertising and sales. So this is our advertising and this is sales. So advertising has an impact on sales. With this particular arrow, we call this as a structural arrow. It is defining the relationship, the structural relationship between two variables or two constructs. So when you have such an arrow, it means that you're talking of a structural relationship. If you have the curved bi-headed arrow, you're talking of the correlation between them, and you're talking of a factor analysis. Let's look at this in real world terms. We have a, we are measuring service quality and we have a scale, and these are the scale items on which we seek the responses from the respondents. So we could have a Likert scale, or we could have a rating scale from 1 to 10, or whatever it might be, or a Likert scale from 1 to 7 or 1 to 5, say. Well, you could have respondents agreeing or disagreeing, or with different degrees. This is one item, this is item 2, this is item 3, item 4, item 5, item 6, item 7, 8, 9 and 10 of service quality. And that is how service quality is measured, because service quality is a latent variable. We cannot measure service quality directly. So what do? We measure it with the help of certain proxy items, and those proxy items are your statements. So we have these statements which end up measuring service quality. Similarly, we want to measure the customer satisfaction, and we measure customer satisfaction with these 5 scale items. And these are the questionnaire items, if you would want to call it. So these are the questionnaire statements on which this respondent has to agree or disagree, strongly agree, strongly disagree, and he has to, these are the questionnaire items. So we have 5 items here which measure customer satisfaction, and we have 10 items here which measure service quality. Now what we can do is, this is the correlational path, the double-headed arrow, as you can see, the curved double-headed arrow. We can run a CFA analysis. So whenever we see such kind of curved bi-headed arrow, we know it's a confirmatory factor analysis. So we will run a CFA to see whether these SQ1 to SQ10, these items, they actually load on to service quality. And when we say load on, that is, does the software actually confirm that this is the factor structure? Okay, and in this, when we run the CFA analysis, and we'll run it simultaneously for customer satisfaction, we want to see if all these scale items load onto a factor called as customer satisfaction or not. Now, obviously, the software will not tell us the name of the factors. We have to give them the name, but the software will tell us that these 5 are different, and they part particular factor 1 or factor 2 or whatever name you would want to give it, and similarly these are clubbed together and they form another factor which you may want to give the name of service quality. So that is what we call as a CFA exercise. Now you can take this one step ahead. Now a CFA can is a precursor, like EFA. CFA is also a precursor to some other analysis, and that analysis usually is structural equation modeling. Now in this is an example of a structure equation modeling. As you can see, now what has happened, the curved bi-headed arrow has been replaced by a single-headed straight arrow, which depicts the causal path that service quality has an impact on customer satisfaction. This is what it is trying to depict. The same thing, you can relate it with the example that we're taking up. Advertising impacts the sales. Similarly, service quality impacts customer satisfaction. Now, this is a structural equation model. And this line, the arrow that you see, is the structural relationship arrow. It is defining the relationship between these two constructs. That is why it is called as the structural relationship. Now, there are two things to structure equation modeling. In structure equation modeling, you can do the CFA analysis is also done simultaneously. Why? Because when we are doing a structure equation modeling, and we are doing a modeling with latent variables. When we say latent variables, we are talking of all those things which cannot be measured directly. So in this, what you see is you have the service quality, and service quality is being measured by all these scale items. Similarly, customer satisfaction is being measured by all these scale items. So these are all latent variables. So this is a latent variable and this is a latent variable, and the relationship between the latent variable is depicted by this arrow, which is what you call as the structural relationship, and that is where the word structural equation modeling comes from. So this is an example where you have only 2 variables and you have only one structural relationship. You could have a model where you could have multiple structural relationships. So basically put, a SEM analysis incorporates multiple regression or regression analysis plus a CFA, and both these things are done simultaneously. So that is why when you become a advanced user, or I should say, when you become when you have advanced understanding of structure equation modeling, you may not want to be doing the CFA analysis separately. You may just want to run the structure equation modeling, which I normally tend to do. So I normally tend to run the structure equation modeling, and I don't do a CFA analysis, because CFA analysis is also done simultaneously when we are doing a SEM analysis. Now, two important things here. Let me just take the. So this, what we see here, this one and this another one, these two are what we call as the factors, and sometimes people tend to call these two as measurement models. Why do we call them measurement models? There's a very simple reason. Because customer satisfaction is measured with the help of these 5 scale items. Similarly, service quality cannot be measured directly. It is measured with the help of all these 10 scale items. So we call this as a measurement model. We call this as a measurement model. So depending on the number of variables that you have in your CFA analysis, it is going to, they will all be called, or even in your structure equation modeling model, even if you have 5 variables, they'll all, each one of them, if they are latent variables, they're called as measurement model. So this is a measurement model 1, this is a measurement model 2. Now the important thing for you to note, once again I'm reiterating this point, is that this particular line or this particular arrow, as I'm trying to tell you, this particular arrow is basically depicting the structural relationship between the two constructs. Service quality has an impact on customer satisfaction, and that is why this particular arrow is what we call as the structural arrow. So I hope now the difference is clear to all of you. And the difference is that EFA and CFA are part of the same family. That is, their parents are the same. So EFA, CFA, the same type of technique. Regression and SEM, same type of technique. Now you may ask me, what is the difference between regression and SEM? The one major difference, there are many differences, one major difference between CFA and SEM is that in regression and SEM is that in regression, we do not have latent variables. We do not have latent variables. Even if we measure service quality, a lot of people measure service quality, and what they will do is they will create a composite variable. That is, they will take the average of all these 10 scores and they will create one observed variable which they will call as service quality. And then service quality would not be depicted like it is being depicted here. Then you will just have a simple model where you will have service quality. This will be your SQ, and you will have another simple model which will be your customer satisfaction. In customer satisfaction, you would also have done the same thing. That is, you would have averaged all these and you would have taken an average of all this and you would have run a regression analysis. So MOS is also capable of running a regression analysis, but the results are the same when you run a regression analysis in MOS and when you run this regression analysis on SPSS, the results are absolutely the same. So the point that I'm trying to make here is that softwares like MOS or Lizrel, they are capable of modeling latent variables. And when they are capable of modeling latent variables, you are in a better position. This is the power of MOS, and this is the power of these visual softwares which are able to model latent variables, that you are able to get the right answer, the correct answer. So let's again summarize the whole discussion. The discussion that we had was what is the difference between CFA and SEM? CFA and SEM are two completely different techniques. But why people tend to confuse CFA with SEM is that because of a simple reason that most of the time people tend to use softwares, visual softwares, or softwares which have a graphical user interface, and they show you the part diagram visually. That is where people tend to confuse between CFA and SEM. In terms of the technique, in terms of how the analysis is run, CFA and EFA are similar and their parents are the same. Whereas if you look at multiple regression and if we look at SEM, they are very similar. But what happens in structure equation modeling is that we are able to model latent variables. So essentially, SEM is an exercise or is a technique or is an analysis which also does the CFA analysis, and it also runs a multiple regression simultaneously and it gives you the results. But the confusion is not because of this, because this is something which very few people know. This is something which very few people, very few researchers actually know and practice. Most of the time, people end up doing an EFA analysis followed by a CFA, which is wrong in most of the cases. And then they do something which you call as a structure equation modeling. So if you have to do a CFA and if you have to run an SEM, many times you can just skip CFA and you can straight away do a structure equation model, or you can run a CFA SEM analysis and it will do the CFA analysis for you simultaneously. So you can examine the model fit indices and everything which is required. And then you can look at your results of your structural model, and you could draw your own conclusions. But this is not what people tend to do. People generally tend to do a CFA first and then do an SEM, and then they are still confused between CFA and SEM when they do these two things separately, and they know that these are two different concepts, yet they end up getting confused in terms of what CFA is and what SEM is. So I hope this lecture has been helpful to all of you.